Thank you very much to the organizers for inviting me. I feel like this is a bit of a momentous occasion because it's the first time that I was invited to speak at a workshop where they didn't invite me to speak because of some new innovation they wanted to hear about. They didn't invite me to speak because I have some brilliant insight about the future. They invited me to speak because I'm going to tell you about stories from the past. So I've now reached that senior stage where people care more about, like, I don't know, I'm the grandpa. I feel like I need a rocking chair, but I don't, so I'm going to pull the stool up. And so gather around, everyone. I want to tell you some stories. And I should note that they gave the talk title of the untold story of the arcade learning environment. It's not untold. I see U of A people in the room. You probably heard this before. Sorry, you've heard some of this story before. So it's not entirely untold, but it might be new to some of you. So that's going to be helpful. I should also point out that this talk was a talk that was given a few years ago, so it's definitely not an untold story in that regard. And that talk was given, co-talk was given with Marlos, and so I want to just recognize that some of the slides here are actually, in fact, Marlos's. I couldn't figure out and tease them apart in the end anyway, but okay. With that said, I want to talk, I'm going to do a little bit of history, a little bit of telling the story of how the arcade learning environment came about. And then through that, I want to talk about a little bit of surprises, I think, that came out of that as we went along the way. And then I'll briefly mention, is there still any room? Is Atari relevant at all? And I want to talk a little bit about that, although I don't know if Pablo's in the room, but Pablo after me, I think, is going to go hit on that anyway. So that will probably get the shortest bit, because we'll hear from others on that. Okay, so to set the stage, I think you really have to go back and look at what did reinforcement learning papers look like in the 90s and the 2000s. Like that was important. And so we would develop new algorithms and new ideas, and we would test them on problems, much like we do today. But what was common is what problems we were testing them on. And so we had a series of, I guess we'd call them benchmarks. Back then, I don't think we called them benchmarks. They were just environments that we ran on. And of course, we had things like, the 4 rooms domain, and we could do big problems like a 4 rooms with a taxi, I guess, and there's passengers. So we had like the taxi domain, or we could do continuous control problems with like cart pull or mountain car, things like that. So within a paper, if you go back and look at these papers, you'll see a couple of these very early environments getting reused to maybe illustrate something, and then you'd often then see some environment out of the blue that was just picked off, that was like the bicycle or the octopus arm, or some environment that this was maybe the first time anyone had ever looked at this. And so that was suddenly the results, and they would show, hey, look, we can address this problem too, without any really notion of like, how hard was it to address that problem. That was one thing. We didn't really have good comparisons between environments. And secondly, RL at the time was such that there was a lot of developer, agent, practitioner usage, where how do I connect up my agent to the environment will matter a whole lot and what performance that we would get. And so if someone came along with bicycle, then the question wasn't really, did you do bicycle, but like, what feature representation did you use? How did you represent actions? How did you do timescales? All those things mattered, but we also somehow didn't talk about them very much, and then that made comparison hard as well too. So this is the state of the world in the 2000s of how RL was working. And anyway, so I just want to give that as a sort of background. This is not the untold story also because there's literally a book that has the story in it, at least the beginning of it. If you haven't read The Alignment Principle by Brian Christensen, he has a beginning of a chapter which relays that the origins of the arcade learning environment starts in the spring of 2008 on a beach in Barbados. And that is in fact true. There's missing parts to the story from that book, but that is in fact true. The arcade learning environment's origins consisted of a walk down. So there was a continuous workshop that was running at the Bellairs Research Institute that McGill has on Barbados Island. We would do talks, and then late in the evening, people would walk down the beach, usually find a bar, usually find maybe some alcohol, and then conversations would be had. With alcohol helping maybe lubricate things. But what part of the story was missing of that before we were having that conversation was a talk that happened at the workshop. So like the value of workshops are huge. To hear something coming from someone else and have people riffing off of this idea. That talk was by Carlos Diuk, who doesn't get enough recognition. Carlos was, at the time, was a postdoc in Michael Littman's lab, and had just was working on the paper that you can go find this now, the object-oriented reinforcement learning. And one of the places they validated this idea on was the game of Pitfall. And they didn't just abstract away some abstract notion of Pitfall. They took the actual Atari emulation of Pitfall and they ran their algorithm on that. So I'm sitting in this talk, and of course, they did things that we would not do now when we applied reinforcement learning to these kinds of problems, where they had handcrafted ways to pull features out of the system so we could find Pitfall Harry and we could figure out where they are in XY position on the screen and provide them velocities and accelerations. And we do that with other objects on the screen, and we provide that to an RL agent. And then they showed that they could make some progress. They could get off the first screen of Pitfall. So they're still not really doing Pitfall, but they were doing the real emulator. And so what happened was Mark and I are chatting over some drinks around a bar table. And the question was, what would happen if you did that from pixels? That was the first question. Could you just do it from pixels? Let's not make any assumptions that we're going to pull things out of it, because then I want to do it for all the games. And could you do that? So that really was the origin. And so Mark says in the book, Mark told Brian that he thought it was a stupid idea. And about 3 years later, I recruited Mark into my group to help make it go. So I guess he got converted at some point. Yeah, but the other person that doesn't get a lot of credit is Yavar. So I come back after the Blair's workshop thinking, this is cool. So I need a student that's going to figure out how do we connect to the Atari emulators that we can get. So Stella in this particular case. And so Yavar Nadif was a new master student. I said, let's do this. Let's just see what happens when we run RL algorithms on a bunch of Atari games. And so like part of this was then, how do we actually get this to hook into the emulator? How do we actually pick which games we're going to actually use? Which is another story that I kind of tell you. The 50 game, like Atari has way more than, there's 900 games made for the Atari. But we think about it now, we think of like there's 50 games or 57 games or 60 games. There's way more games out there that we haven't actually looked at. And I kind of wonder if that isn't something we should do. But what Yavar also did was not only benchmark RL algorithms, but benchmark search algorithms and planning algorithms on top of this. And so it really showed what was possible. But that probably still, that came out as a thesis in 2 years later, so in 2010. You can go find his master's thesis. It has most of the arcade learning environment in it, but this still wasn't the arcade learning environment that anyone knows. But at this time, I sort of have this as a platform, and I'm like, I want to do research on this. I bring in Joel Vanessa, so I should mention Joel as well too. And I started tasking Joel, and Mark arrived to say, okay, let's do real research. We've done all the groundwork. Let's figure out how to do real research on this. Yeah, so the next piece that I want to tell you is what happens after that is I'm worried as we have plans for what research I think needs to be done. This research is not DQN. That sort of caught me off guard and by surprise, and I'll tell you about that in a minute. But there was research that I really wanted to do in this space, but I was really worried that it would be hard to do it. I really thought the review community was going to look at this and say, you know, by comparison, you probably all understand now that this is much better than having run on 4 rooms, maybe Joseph might disagree with that, but maybe much better than having run on 4 rooms in Mountain Car, and that's it. But I was really worried that they would look at this and say, oh, you ran on 1 environment, but what does it do on other ones? You know, the gold standards have run on 3, and now I'm going to run on 1. Like, is that how they're going to see this? And so I was worried. So I ran around and did workshops, any workshop I could get into, and it's like, let me tell you about the arcade learning environment and what's going to do. And it was not because I thought I was going to get anyone else to do this crazy idea. I only did it because I wanted the reviewers to be prepared for the papers that we were going to submit. And they would be more predisposed to accept them. I swear to God, that was all I was thinking about. So I'm going to show you some slides from the early, so I'm going to go through some slides from the early presentations that I gave to convince people that this is a cool platform to work on. And that making progress in this space would matter. And you should accept my papers, really. So first of all, if we want environments, if we really want to, the pitch that was being made was to build agents that are generally competent. Let's have reinforcement learning that could work. Maybe it won't give you the best performance on this environment, but instead it would just do a pretty good job of a lot of different environments. It was just capable of learning to do things. And so that means we can't run it on just 3 environments. That's not going to show general competency. And so we needed to have a set of environments that there were enough of them to do this. So we wanted many environments. but we also wanted them to be variable. A common thing that you might see when people did many environments is that they would do something like, I don't know, I could vary the gravity in mountain car. See, I can generate an infinite number of environments with mountain car running different gravities. But that, of course, doesn't really. That just shows that you can sort of work within that very narrow space. And Atari not only gives you many games, there's 900 games for it, but they're all doing very different things. There is, shooters, there's sports games, there's first-person perspective. All of that is built into Atari. So we can get a lot of variety. Now we look at it and maybe say the variety is limited, but at the time, this was diverse. Third thing is we really want them to be interesting, because we could also get variety by generating random MDPs. This was a thing that you would see in the literature. They would literally connect random states of a graph together as MDPs and say, look, I can do well on random MDPs, but are random MDPs interesting? And I was arguing, not really. I mean, like, you as a human probably aren't really interested in taking actions in a random MDP, but here's, again, a set of 900 games which entertain generations of people over decades. So kind of all of these games, by the virtue of humans playing them, are interesting. And lastly, we didn't make them. They're just there. They're out in the world. So when we come along and made Octopus Arm, there was a reason someone made that as a domain. They made it as a domain because they wanted to illustrate something in their algorithms. And then, of course, they could validate their algorithm, which was like, this was the perfect domain for what they were trying to show. And so here, we can now see what are the problems that just arise. Like, where are our algorithms just falling down, and where do they do well, depending on just someone else's set of tasks that were just given to us by being a different set of games. OK, so that was the pitch. And then, then of course, I would show what is Atari games, because now you look at these, and you could probably just start rattling off which game these things are, which is wild to me. But like, what is Atari 2600? This was a console that came out in 1977. It's known as a second generation console, which means it has a general purpose microprocessor. This was the first time that you could go buy games for your game system. Before that, the first generation of home video games was that it just played one game. And it's still, even in the second generation, this is not really the first console, but it dominated the scene for like 6 years, and then continued to be an important factor going forward from that. The main feature of the Atari 2600 is it's primitive. Its resolution is 160 by 210. That's the number of pixels it has. DQN makes us think that the pixel resolution is different because they chose a different one. It had a 128 color palette, but more importantly, the action space is discrete, and we didn't make this up. It just is discrete. The original Atari joystick is literally, like the fire button is on off. The joysticks are not analog, they're digital. There are 18 actions in Atari because there are 18 actions with the joystick that you can actually do. The processor is 1.19 megahertz, which doesn't entirely matter, but it has no frame buffer, if you never knew this. The people who designed for this, they did not write where the things were on the screen. They actually, as the beam draws, they have to change registers to make it draw what's shown on the screen. When the beam goes to the bottom, when the CRT beam went to the bottom and it scrolls up to the top, that's when it did processing to figure out what is going to happen on the next step. But then the other crazy thing is it has 128 bytes of RAM. I didn't misstate any of that. 128 bytes, 1,024 bits is enough to encode the entire state of any given game. Sure, there's like ROM, there's the code that is running, but the actual state of the game is determined by 1,024 bits. So the point is, this is super simple. When I was pitching this to people, I was like, RL should be able to do this. And yet I do not know how to make it do this. But it feels like we're right on the cusp of maybe making it do that. Second important feature is we have over 500 games, and the third important feature is that there are many, they're varied, they're interesting, and they're independent. So we should be able to do this, and I don't know how to do this. Let's see if we can maybe do this together. That was the pitch I tried to make to the community. I would also, maybe make this a little bit more human. These were my 5-year-olds at the time, 6-year-olds. I think they were 6 at the time. 2011, it would have been 6. And I had them actually play through. Let me see, how do I do this here? I had them play through all of the Atari games, and I recorded them. We'll go through a couple of games which I just find funny, and so we can watch what does a human do who's never played any of these games before and doesn't even know how to make they weren't even playing with a joystick at the time. They did have to use arrow keys on the keyboard, but they weren't quite familiar at that time with a lot of video games. So here, you actually see they just sort of discovered the stairs, but then found a moving platform and got thrown off again. But they're constantly experimenting with jumping, but can't quite figure out how to line it up. And eventually, so what they did play through all the games, but the minute the game was over, they didn't play that game again. It just went to a random Atari game. with the thought being that maybe this is how our agents should actually experience Atari. It isn't how we actually use the benchmark, but that's what I thought. This is a game Ice Hockey, which I found it hilarious. So my son Andrew here, by the way, my son is now 20, so this is always disturbing when I look back at these videos, how much time has gone by. But when he was playing this game, he was very excited. He was convinced through the whole 10 to 15 minute game that he was winning as he was scoring goals left and right, but lo and behold, he was not yellow, he was blue. But he never did quite realize that through the course of the game. So sometimes it's even hard to figure out what you control in these games, which I thought was really interesting. I'm going to jump ahead. I can find my cursor. You won't be able to hear this, but they played the game Freeway. I don't know if you know this. It's chicken crossing the road. Maybe I'll see if I can turn this up. Oop, that's not what I wanted. Oh, shoot. Try this again.
There's the bell.
Okay. So what he was doing the entire time he was playing the game was not even really trying to get the chicken across the road. If you listen for a second. All he was doing was holding the up arrow and then vicariously living the life of the chicken of going, wee, I'm going across the road, and then accidentally hitting by a car, go, oof. And was no longer avoiding the cars, just wanted to experience that. And I just thought it was hilarious that it didn't matter what goal was set by the game. He was just going to do whatever he wanted to anyway. And in early Atari agents, we almost never saw that. Okay, so what could we do with Atari? So after I pitched all of this reason why this is a great benchmark, we could do reinforcement learning with it. We can, of course, do model-based reinforcement learning with it. Like we could have the AI system try to learn a model of how games work and see if that can improve things. We could do apprenticeship or imitation learning by taking expert trajectories and what do they do when they play these games. We could look at hard exploration problems like Pitfall. If you don't know this, like Pitfall still to this day, I think remains a hard exploration problem. There are versions of people tackling it, but they do it usually by using things like I'm going to take YouTube videos. We need to add extra information in order for this to happen. But in Pitfall, it takes approximately 1 minute and 45 seconds of determined action by a human to see any positive score. And almost anything else you do if you don't follow that exact trajectory is a negative score. So that still remains a hard exploration game. We can think about transfer learning. There is Pitfall to Pitfall 2. Pitfall 2 is another game. It obviously has similarity. We have seen almost no transfer to this day, I think, happen between games in Atari, and I'll come back and talk about that in a minute. We could also think about intrinsic motivation around there's a score, but is the score really the right thing that you should be pursuing? Again, the game of Pitfall, I don't think it's if I told people what you got points, if you had ever remembered Pitfall, if you're old enough to remember Pitfall, and I were to ask you, how do you get points in this game? Almost no one who played the game actually knows the answer to that question. You get points. What felt like you did, your job was to see more of the game. And that's what you tried to do while you played. Turns out you got points from getting gems. Who knew? But obviously we had intrinsic motivation as we played these games, and our AI systems still, maybe we've touched on that with some interesting research. All right, that was the pitch. But it was more than that. It was more than just environments. I was pitching something else too at the time. And if you've never read the Arcade Learning Environment paper, I recommend it because you can find out all kinds of things that you don't know about, even though you might have used Atari as a benchmark. For one, the pitch that was made was you would have training games. You were designing an algorithm that's supposed to have general competency. So you should take a set of games and design your algorithm only running it on those games. And then what you're going to use is then go run it on 40 games you haven't seen before. It's like a test set, and you'll find out how well you did. And then, the idea would be that you would not be necessarily looking at how do I turn up my performance across the whole suite that we do now, but rather that I would just be focused on how do I improve my work on the training games. I think to this day, RL has not been successful at anyone following this methodology, which is too bad because it was an opportunity to do that. This work, of course, appeared in a JR paper. That's sort of what grabbed people's attention. And right as I was doing these talks at workshops, I was preparing this paper. I presented this at the University of Alberta and what the arcade learning environment we could do. And of course, the University of Alberta is known for this guy, who's always usually sitting in the back of my talks. But not today. The other time I've given this talk, turns out he walked in right when I put up the slide, which is absolutely beautiful. And this is what he thought about it. you're going to ruin reinforcement learning. I was like, no, Rich, no, that's not going to happen. Like you bring up these bad things. It's like, people are going to over-fixate on scores and chasing scores and trying to improve leaderboards, and they're going to focus on, not really caring about the science of what's underneath things. I was like, Rich, no. So that's not what's going to happen. Like I know how to do this. So when I was giving talks on this, I actually had a slide that I got to, like when I was done with my talk. I had this extra slide that was the very next slide. So then when I went to questions, invariably the first question or the second question was always the same thing, which was, I think actually Julian was at one of the talks that I gave this to. Yeah, that's right. And the very first question was, will there be an Atari competition? And so then that was my next slide so that I could just tap on my screen. So this is my answer to Rich. Like, we're going to avoid this because we're not going to make it a competition. It's going to be more like ImageNet or like the machine learning repository of just lots of data sets. And we can trust peer review to focus on what matters. Okay, but I don't think I was that wrong. I mean, look at what happens next, right? Not long after that. So this is 2012 paper comes out. By 2013 already, is the workshop version of what becomes DQN. That then comes out over a year later into Nature, right? So now we have a game that really can straight from pixels, an agent that's straight from pixels, can learn to play, on average, definitely, above sort of an average human level, and more than half the games is doing that. So we have some of these famous pictures, especially the one on the right, showing that in some games it's doing extremely well. It still wasn't beating this sort of prototypical human on every game, but that's pretty exciting. I mean, at the same time, this starts an explosion of deep RL, right? And some people think of this as like some field unto itself, which still blows my mind. It's still just reinforcement learning. But we're now seeing deep RL workshops. What was it, by 2019? There's like the deep RL workshop at NeurIPS has like 700 people sitting in a workshop. It's a workshop bigger than this entire conference at NeurIPS. The other weird thing that happens is, can you guys name these games? What's the one on the left? What's the one on the right? Isn't that strange? Why is it that anyone knows obscure Atari games that came out in 1980? And now they're just like on, this just blew my mind when I was at the Deep RL workshop in 2019, and people would just put up Montezuma's Revenge. It's just like, that's a thing you should just put up on the screen. So here I was trying to convince people to accept my papers. Meanwhile, lots of other papers were being written and focused on. And of course, cool things came out. Like Deep RL has gone on to do cool things, right? Deep RL has been used to fly stratospheric balloons. We had a talk on GT Sophie and racing. We can control fusion plants. So Deep RL has found a role to play, and a lot of that was started because of the arcade learning environment. So I don't know, Rich, was I really wrong? Okay, so let me switch gears and talk about some things that I learned from the arcade learning environment. How much time do I have? No one's tracking? This is you're all placating the grandpa sitting in the front of the room telling stories. I get it, okay. We'll come back to Rich. Yeah, maybe we did. Maybe he's right. Maybe we did do a little bit of, ruining RL. I didn't get an actual quote from a reviewer, but there were certainly discussions running around the U of A of people producing lines from reviewers that looked exactly like, but where are the Atari experiments? Especially for Rich, for which, Rich's process is one of thinking very carefully about the important scientific questions and then doing experiments that directly answer that scientific question. Having someone come and say, where are the Atari experiments, did not make him happy. At the time I told Rich, of course, again, the reviewing community is smart. They're going to see that your thing that you're working on doesn't warrant an Atari experiment, but that isn't exactly how it happened. Secondly, we have some other problems. This idea that I expected people to do this, that isn't what happened, right? What happened was there's now just 50 games. People will do what they want to do, and you can tell them to do something, and they won't do that. They just do whatever they want to do. That's fine. Like crazy things like maybe we'll just tune the hyperparameters per game, which would have been like, what? Like if you ask me, but like people will do what they're going to do, and the review community is a bit random and who you get to review, and so that's just fine. Now we're going to tune hyperparameters over all the games. Maybe we'll run for 5,000 episodes. Maybe we'll run for 200 million frames. Maybe we'll run for 100 billion frames. Who knows? Just my score's higher than your score. Look, I got a paper now. That was the Wild West that we were in for a long time. Maybe we're out of it. I don't know. Maybe we're not out of it. It's still the case that just if you produce a higher Atari score on some game than somebody else, that just automatically counts for something. And that's kind of not okay. Rich is right about that. That's not okay. Leaderboards can be misleading. Exactly this. So one example that we had given early on. So we ran a workshop not long after the arcade learning environment came out, and so we had a lot of people who were now working on it and looking at what was happening. And there was some work that first got presented there that got incorporated in a later journal article on the brute. The brute was not a serious algorithm. The point of the brute was, what if you did the dumbest thing in the world? Like, what if I just find a really good sequence of actions that works well on this game, and I'm just going to do that because Atari is deterministic. If I take the exact same sequence of actions, then I will see the exact same sequence of observations. So my policy could in fact be open loop, and it could just be a long sequence of actions that does really well in Space Invaders. And so could you find like a search algorithm that finds a good sequence of actions? That's all the brute did. And we were able to basically half the time beat DQN and half the time not beat DQN. So the point of this was to say, wait a minute, maybe we should be looking at scores because this is a dumb algorithm. But it wasn't always seen that way. I think I've seen people point to the brute going, that's a clever idea. We should figure out how to do that. But we should be careful about this. And as we're doing benchmarks now, we should be careful about it. I think, I don't know who asked about the NetHack benchmark, but someone asked, Joseph asked, what is your goal? What do you want to see people do? And I think carefully thinking about that and curating how the benchmark gets used will make it more likely that you'll get people to do the thing that has the maximal impact and not something that is just chasing scores. We also saw overfitting algorithms. So for example, this is, and I don't really want to pick on random network distillation, but there was a whole race of people to try to tackle exploration in Atari. And so they took the hard exploration games. Montezuma's Revenge is known as that, Pitfall is known as that. And they would go and take them and then say, like, look how amazing it is. Like, I have a 500% improvement over DQN on a game like Montezuma's Revenge. And if you run this on all the games, then this is what you see as terms on the average performance. Like many of the games, in fact, most of them, over half of them, you're actually just hurting yourself. And as much as the improvement you're gaining on Montezuma's Revenge, you're going to lose it somewhere else. So like we started really overfitting on games. We started calling them, because this problem is hard. Then we started thinking, well, that problem is hard in isolation, and stopped thinking about the benchmark as being something that we holistically are trying to make progress. Some of these problems we then came back. So I would recommend this. Maybe even NetHack at some point might need to come back and do this, is say, okay, we've now seen people try to tackle this. Let's go review what's been done and try to see if we can do a course correction. And so we did this with the workshop, but then turned into a paper. If you haven't read the Revisiting the Arcade Learning Environment paper, I'd rather, if you only read one of them, read this one, because this one is what happens when you realize people doing wrong things experimentally and then trying to see if we can help the community do things better. One of the things we did was to just make sure that the Atari wasn't deterministic anymore. And we were very careful that we made that the default option. So if someone just downloads the Arcade Learning Environment, they get the sticky actions one, as sometimes people know. And this way they won't accidentally fall for the trap of like, let me focus my algorithms on and exploit the fact that it's deterministic. But we also try to build in better processes to help people evaluate things so they don't make common mistakes. I do want to make one more shout out to Marlos. Marlos, I've heard him say that this paper was the biggest accomplishment of his PhD, even though it didn't appear in his PhD at all. There were 6 authors from 5 institutions. 2 of them were companies, including a company for which this paper was probably somewhat critical of their landmark result. And so getting this paper through publication was, not through the reviewers, through everything else, was a challenge. So kudos to Marlos for pulling that off. So let me come to this last bit. So is Atari useless for advancing RL now? Like, you brought me up here to tell you old stories from the good old days, and maybe it's not relevant anymore. I mean, my thought is much like other things, that no, of course not. In fact, like, I mentioned what you could use this for: model learning, exploration, intrinsic motivation, transfer learning. I don't think we've really done almost any of those things effectively inside of Atari. Maybe some of it is because we've started to learn that some of the things we thought maybe were possible maybe aren't, but I'm still not convinced of that. Okay, a direction that we were not thinking about 15 years ago is continual learning, and I think that's an important one, but it relates to this sort of transfer bit. Like right now, the way we sort of run our algorithms in Atari, right, is they're going to play the game of like Space Invaders, they'll run for a very long time, they have a good policy, and then they'll like take the game like Demon Attack or something else, and they'll play that game for 38 days, and they'll have a good policy, and so on. But I mean, these three games are different according to Atari, but visually, they're the same game. But what we have yet to see anything actually do transfer between these things. Like they're all just you're at the bottom with the shooter trying to shoot things that are at the top. There's even more. I think there's a total of 5 games that essentially have this motif. So you would think that there would be an opportunity that an agent either continually learns, could take advantage of this, or even just seeing transfers possible, and we're not seeing that. And in case you haven't been paying attention to Atari, when we did this re-release, we also released with Atari more than that. Atari, as a console, used to have little switches on the console, and if you flip the little switch, it would actually change how the game was played. Many games had multiple modes. You had to physically flip a switch to go see these other variants of the game. So when we released the games, we didn't release any of those other modes. All of these games typically have, many of the games typically have like 5 to 16 different modes of how you can play them. They're all kind of then the same game, but then slightly different. And what's wild is that if you go train something on freeway mode 0 and go run on any of those other modes, it performs 0. It doesn't cross the road a single time. But again, they're largely the same game. It's move a chicken up and don't try not to get hit by cars. I don't know if this is, anyway, we'll skip the rest of this video. Apparently that was it. So that's what I want to tell you, because I know Pablo was coming after me to tell you more about how we could use Atari in new ways that are useful still in 2025. But thank you all for your attention.
Thanks a lot, people. I think we'll now take some questions, if any. Yes.
Yeah. Oh, we'll do the first one here.
It's a very good talk. I wanted to ask, do you think that maybe some of the questions that you think that you were presenting that are left to solve in Atari might require stepping stones that are outside Atari?
I think it's probably true. I think as I think about continual learning now, maybe not even 5 years ago, but definitely not 10 years ago, I think if we want to see like a continual learning Atari agent, if I think about what my kids were doing when they were approaching Atari games, they had a much broader set of experiences before that moment. And so if we just then expect an agent to sit down and hit game 1, game 2, game 3, game 4, and do anything that what we might expect a human to do, it's just not at all the same experience. And so, maybe some people might look at this and see a curriculum problem. I'm not sure that's how I think about it, but I think there is this question about like what I want to see. Like I gave the answer to what do I want to see for a benchmark. I don't know what that benchmark looks like, but I would love to see very long-lived agents. Like right now, we think about running our agents for, I don't know, like sure, like maybe 38 days of Atari time isn't outrageous, but like then they've learned an optimal policy and then we're done. We don't run them again. But like we don't really make agents that live lives that just have lifetimes and just keep learning and the world changes on them and they build up vast arrays of knowledge. I want to see something like that. And I think Atari could be related to helping us get there, but I'm not sure exactly what shape it would take. But it would definitely pull stuff outside of Atari to do it.
Thank you.
You said that DQN took you by surprise when it arrived, but you also said you had this like massive research agenda around the ALE. So if DQN had not happened, would you have gotten there? What detour would you have taken? Or like what's the counterfactual? Yeah.
Yeah, it's an interesting question. I mean, at the time, I was still in the camp of I like convex optimization because we can reliably reach the global minimum. And so like I just had that bias. I've since, not just that because of performance, I think I've started to understand better about what's happening inside of these non-convex architectures, and so that's helped a lot. But I'm certainly someone who comes at things from a more principled point of view than just it works, so that's what I'm going to do. So I don't know that I would have gone to. I think it needed someone else to go to that, and I don't think I would have. If you want to know what we would have done, we did it anyway, kind of. Like we wrote this paper called Shallow Human Level Control in Atari with Shallow Reinforcement Learning. That's what we would have done. And in fact, we matched and maybe even slightly exceeded, I think, DQN results without even needing Deep RL at all, which is wild to me because there's another counterfactual going on, which is what if DeepMind was slightly slower at doing DQN, and we do that, and that becomes a state-of-the-art benchmark, then we don't see a big win. Or if we had released the arcade learning environment with that shallow reinforcement learning benchmark, we don't see the big win of DQN, and Deep RL doesn't take off, and then I don't know what happened. Like that's such a weird counterfactual that like we made like there's a weird one of these just so. It just happened just to be just so that the RL algorithm that we put a benchmark for was not particularly strong. And we weren't, it was within the space of possibility that we could have had a much, much stronger one. And that just wasn't what was in there. And I think that shaped history in a very funny way.
Okay, perfect. Can you maybe speak a bit on the balance of two extremes, which one extreme that you mentioned, well, we have a benchmark and then people start to overfit and chase numbers, right? But then you have the other extreme, which is you can have people who can say, well, I don't chase numbers, I do the real science, and they come up with their like own small benchmarks to do something that might be interesting for them, but doesn't really move us forward, right? Which like if it wasn't for ImageNet for Vision, we would also not be moving forward. So like where do you see the balance?
Okay, as much as I told you a story of I put a lot of trust in reviewers and then I was disappointed, and then my answer is I just put trust back in reviewers. I don't know, maybe I'm just like an eternal optimist, but I think we as a scientific community have control over this, that we should absolutely take papers that are going to like make a massive jump on a benchmark like NetHack and make huge progress on that. And even if it isn't like scientifically rigorous underneath, we can still prize that and put that in, look at that publication, see those talks, learn from that, and then see scientific work come after that. And at the same time, allow someone to say, I have this very targeted scientific problem, I have this toy thing that's going to illustrate it, and I can make progress in that way too, and we can see those papers as well too. I think we can do both, and it's just a choice that we have to make as a community, that we review papers on the terms that they are set out to what they're trying to accomplish. And I think we, as reviewers for reinforcement learning right now, have that within our control. We don't have to be dogmatic about, but where's your state-of-the-art numbers? Or, I guess what would be the other criticism? You don't have any scientific principles, so then I can't really judge the value of your work. You just made that number bigger. I think we don't have to be one or the other. And I think that's just a choice of us as reviewers. So I don't know. I'm still eternally optimistic that the scientific method and peer review actually works. I actually think the experience of arcade learning environment, I think as much as I have this sort of joking, Rich thought we did huge damage, I mean, Rich at the same time probably doesn't win a Turing Award if Deep RL doesn't happen, right? Like he knows that too. So like, I don't know, I'm even sure this was a failing of the peer review process. Maybe it really was just, it has hiccups and it has starts and stops and it's not great at every moment, but maybe this is just the scientific process working. So maybe as much as I went through this, I'm optimistic, I'm pessimistic, I'm optimistic, maybe it's just more even, and that, we're gonna see some unluckiness, and sometimes our papers get, you get that review that says, but where are the Atari experiments, when they're not the appropriate ones anyway. Callie over here, right behind you.
So it seemed like at the end of the talk you were saying, okay, we can still use Atari, and there's all these open problems, but I guess it's more like, should we? Because I feel like I hear from a lot of like grad students here at the U of A saying, okay, Atari, it's like very compute heavy, it takes days and days to run. Like, is there better benchmarks we should be using to like evaluate some of these open problems?
I think the question is related to what I just said. What is it that the research direction you're going needs to have answered? I love RLC's review criteria of saying, let me write down the contributions that you're making, and then we're going to see, did you provide evidence for those contributions? Because that's kind of what matters. And so if your contribution is going to say something about, we're creating a state-of-the-art method that can apply generally across lots of different environments, then it's probably not okay that you ran on some small toy grid world environments. On the other hand, if what you're trying to illustrate is something about memory or non-stationarity, then that might be a perfectly reasonable choice for the claims that you made. So yes, Atari is a more compute-heavy benchmark than others. I do think there's many of the other sort of similar, like probably the best other example of varied many interesting people might go to might be on the control side, Mujoko, or maybe DM control. I'm not sure, there might be slightly less compute heavy because you can get them to run, in some cases you can get them to run directly on GPU and take advantage of that. And that is certainly a win that you don't have with Atari right now, and that is potentially a plus. But I think the varied side and the independence of those are not as strong in Atari, right? Like, I don't think the Mujoko tasks are largely that different in terms of what algorithms will work and what won't, in the same way that I think you see a much more variety in Atari. And I also think the independence, like we design those problems exactly because we have control tasks that we want to run on them.
Thank you. And, yeah, thanks a lot, Michael.
Thank you.